Okay, we are going to be looking at identifying similar shapes. The very first thing is that they have to be the same shape, or it's not possible that they are similar. So I know I'm going to be looking at all my rectangles and determining which of those are similar. Then I'm also going to be looking at my triangles to see which of those triangles are similar to each other. Now that I've categorized them by shape, the light purple ones, those are all rectangles, and the yellow ones, those are all triangles. Now I go to my second criteria to be similar. Second criteria to be similar is that they have same corresponding angles. So, I'm going to start by looking at my equilateral triangle over here at E, and I can see that all of the angles in E are 60 degrees. In D, all of the angles there are 60 degrees. As I look at my other triangles, I can see that they don't have equivalent corresponding angles. Corresponding mean this in the same location. So now I'm going to start looking at my other shapes. I can see I have a few right triangles on here. So quickly I'm just going to turn my right triangles blue so we can see that that's what we're looking at. Now I'm looking to see if they have the same corresponding angles, the same angles in the same places. So I can see that here there is a 90-degree angle, 90-degree angle here, 90-degree angle here. It does not matter if the shape has been rotated. It can still be similar. And then I can see that there's a 55-degree angle here on the shortest side of our triangle. So now I look at my shortest side of my triangle here. There's a 45-degree angle. So already I can see that they are not the same angles in the same corresponding spot. So I'm going to change K to a different color. Let's call K green. And I'm looking now only at the two blue triangles because I can see that they have 45-degree angle, 45-degree angle, 90, 90, 45, 45. And here I can see that in F, there's a 110-degree angle. In G, there's a 110-degree angle. The angle that connects the longest side with the middle side is a 25-degree angle. The side that connects the longest side here with the middle side is also a 25-degree angle. And here I can see the short side to the middle length side is a 45. Looking at the short side to the long side, there's a 45-degree angle there. So, they have the same angles in the same corresponding spot. The next thing I look for is, do they have equivalent ratios? So at this point, I write ratios for my figures. I'm going to be starting with my rectangles. A ratio is a comparison of two things, often written in the form of a fraction. So if I look at figure A, I could write a ratio of 2 to 3. In this form, I could say it's a ratio of 2 to 3 in this form, or I could say it is a ratio of 2 to 3 in fraction form. The form that we are going to be focusing on here is fraction form because it allows us to do some different mathematical things a little bit easier. So I'm going to erase these other ones. Okay. The ratio in figure A is a ratio of 2 to 3. Again, a ratio is a comparison of two things, and the two things that we know about figure A are that it has a side of 2 and a side of 3. Next, I'm going to treat this ratio as if it's a fraction and say, can that ratio be reduced? And it can't because 2 is a prime number and 3 is a prime number. Next, I look at figure B. Let's say, what is the ratio I could write for figure B? Because in figure A, I did the short side first on the numerator and the long side in the denominator, I need to continue that same pattern. So in figure B, I need to do the short side first and the long side as the denominator. And then again, I'm going to treat it like a fraction, say, can that be reduced? In this case, it can be reduced. Both of them are even, so I can take the 4, divide it by 2, and take the 6 and divide it by 2. Now I'm actually dividing it by, maybe I should write this differently. I'm actually taking this and I'm dividing it by 2 over 2 which is the same as dividing it by 1. And remember that dividing by 1 does not change the value of something. 4 divided by 2 is 2. 6 divided by 2 is 3. So that's saying that the ratio of 4 to 6 is equivalent to the ratio of 2 to 3. Then I come over here to figure C, and I would write a ratio of, again, short side first, just like I did with all the others, 2 to 6. So I have a ratio of 2 to 6. And then I'm going to treat it like a fraction and say, can that be reduced? They're both even. Even numbers are divisible by 2. So again, I'm going to divide it by 2 over 2, which is equivalent to 1, which tells me that I'm not going to change the value of my number. So 2/6 is the same value as 1/3. Now, in order for shapes to be similar, they have to have equivalent ratios. At this point, I can see that figure A and figure B have equivalent ratios, whereas figure C does not. So now I can say figure A is similar to figure B. This right here is the symbol for similar. Now I know my rectangles. I also need to determine which of my triangles are similar. So I'm going to be looking at my yellow triangles, and I'm going to be writing ratios for them. When you're looking at triangles, you can pick any two sides to write ratios for, and to be careful, you might want to do more than one set. So if I was going to write a ratio for figure F, I'm going to do short side to long side, but know that you can write a ratio for any two sides as long as they're the corresponding sides in the other one. So I go 2 to 4. So this is my short side and my long side. And I can see that 2 to 4 reduces to 1/2, or 1 over 2. If I go to G, again I need to do corresponding sides, so since I did the short side on this one, I need to pick the short side on this one, which looks like a 6. And since I did the longest side in figure F, I need to pick the longest side in figure G, which is 12. So this one has a ratio of 6 to 12, which also reduces to 1/2. Now I can see that they have equivalent ratios. I would also go back and again double check my angles. I can see 110 here. This also has a 110-degree angle. 45-degree angle here. This also has a 45-degree angle. 25-degree angle here also has a 25-degree angle. So same shape, same angles, and equivalent ratios. That means that triangle F is similar to triangle G. Now I'm going to be looking at my blue triangles. If I write a ratio for J, I could do an 8 to 8 for those two sides, but I think I'll pick the long side again and just one of the shorter sides. So I'm going to write this as a ratio of 8 to 12. Again, you do not always have to do the short side as the numerator. It's just something that I prefer to do. This is the long side. And 8/12 reduces to 8's divisible by 4, so that would be 2. 12's divisible by 4, so that would be 3. So reduces to 2/3. And then if I look at I, and I do short side to long side, I can see that that also is a ratio of 2 to 3. So that means that J is similar to figure I. Now just to prove a point, I want you to notice that if I wrote a ratio for figure K, the green one, it would have a ratio of 2 to 3 as well. So the reason that it's not similar is because of the angles. Here you can see we have a 90-degree angle, 90-degree angle. K does have a 90-degree angle. Then we have 45-degree angle, and K does not have a 45-degree angle. J has another 45-degree angle, I has another 45-degree angle, and K again does not. So while their ratios are equivalent, since their angles are not the same, they cannot be similar. So don't forget to go back and check those angles. Now if we look at the equilateral triangle, we can write a ratio with any two sides. And let's say we chose these two. It's a 3 to 3 ratio, which is equivalent to 1. And D has a 2 to 2 ratio, which is also equivalent to 1. Since their ratios are equivalent, and both of them are made up of three 60-degree angles, then that means that triangle E is similar to triangle D.